Hey guys, we're going to talk a little bit more about energy, specifically heat energy and energy transference using convection, conduction, and radiation. One of the things that you could potentially do is cook some dinner with your family. Try not to do it on your own. It can be pretty dangerous if you're using hot pots and pans and water and whatnot. But what I've done is I've started up my stove with some food that we're going to cook, something that you might actually do. We're going to do grilled cheese and ramen soup. So I wanted you guys to get a chance to see where conduction, convection, and radiation are happening already. So if I take this pan off, you'll see that I've got a big burner down here. All right, and those burners get red hot with coils underneath, and then those burners transfer their energy to the pans. Now the pans are technically touching the stove and not the burner. So first the burner heats up the stove, and then the stove heats up your pan and your pot. Okay? Because these things are touching, we call that conduction, right? Conduction is heat transferred by touch. So we have a warm pot of water. That is actually the pot itself is transferring its energy to the water as we speak, which is starting to boil. I'll try to get a better view of that in just a second. And our pan over here is getting nice and warm. And how do I know that? If I put my hand over it, I can feel heat waves coming off the top. That's radiation. Okay, radiation is heat waves. So if I put my hands nearby, I can actually feel the heat coming off of these things. So I want to put a couple of sandwiches in here, start transferring the heat from the pan to the sandwich in the form of conduction. And we'll know that conduction is happening. You can hear the searing of the butter that's on the bread. Okay, so what's happening here is the energy that's in the pan, the molecules are moving around really fast, and now they're starting to make the molecules on the butter, on the other side of the bread, move around really fast as well. Hence the idea of energy transfer. So I'm going to start buttering the other side of this, and I'm going to move over here to the pot and give you a little better view of what's going on down there. You're starting to see some bubbles rise up from the bottom. That is what we call boiling. But what you're going to see in just a moment here when I drop the noodles in is that when the water starts to boil, you'll notice that it will rise up to the surface and then sink back down to the bottom where it warms up again. So it comes up to the top where the air is nice and cool, and then when it does, it cools off, it shrinks, becomes less dense, and it sinks back down to the bottom where it heats up again. And I think that cooking pasta is the absolute best way to show convection aside from a lava lamp. So here are my noodles. I'm going to drop those right in there, and we'll see what ends up happening. Now also notice that I'm not using the oven right now. The oven is a great way to show convection as well, as this happens to be what we call a convection oven. Basically, there's a fan that forces the air up and down around everything, and it actually makes it heat up and cook quicker than a normal oven. My plan was to make brownies too. I don't know if I'm going to have time to do that. If I do, I'll make another video and add it as an extension to this. But for right now, your responsibility is to tell me where is convection, conduction, and radiation happening when you cook dinner. So conduction is when two things are touching and heat energy is transferring from one to the other. Convection is when you see a flow of matter. Hot stuff rising, cold stuff sinking. Could be air, could be water, could be noodles. If you have boiling water with mac and cheese, it illustrates it really, really well. Those things are considered convection. It happens in the air all around us. It happens in the magma under the earth. You need to find out where it's happening when you cook. All right? And last but certainly not least, we're talking about radiation. Now, radiation is heat waves. that means that heat is being transferred without using any matter at all. It's just infrared waves, infrared radiation, as we like to call it. So let's see how this boiling water is doing now. It's starting to pick up. I know you're saying, Mr. Spader, we're actually watching water boil? That's so boring. Well, just trying to help you guys out a little bit. I'm going to flip over these grilled cheese sandwiches. A little dark. It's because I was talking to you guys. So as these noodles start to come apart, you'll actually see that the water inside is starting to bubble up. And that. So just a reminder, I'll be in my classroom at 1 o'clock to start talking about the video and to answer any other questions you guys might have about any of the other options that you might be choosing to do. Again, cooking is not something that needs to be done right now. You could do it on Friday if you want. You could do it on Thursday if you want. So you can see the bubbles are starting to come up through the middle and starting to percolate up. That is the hot water and bubbles starting to rise together because they are hot. And we know that hot air, hot water, all rises. So that's a good illustration of convection right there. I'm not going to bore you with watching a pot of water boil for the next 10 minutes while I wait to eat my lunch. But it gives you an idea of where you can explain these things are happening. All right, watch the video. We'll see you guys around 1 o'clock.